If n is an odd positive integer, show that n square minus 1 is divisible by 8. Let's understand this. We are given the expression n square minus 1 in which n is an odd positive integer. Positive integer, odd positive integer. Now given this, we need to show that n square minus 1 is always divisible by 8. Now this can be factorized as n plus 1 into n minus 1. So we need to show that n plus 1 into n minus 1 is always divisible by 8, where n is an odd number. See this example here. Let's consider the odd number 17. Now when n is 17, n minus 1 is 16 and n plus 1 is 18. We need to find n plus 1 into n minus 1, which is 16 into 18. Now see the product. 16 is divisible by 4. 18 is divisible by 2. Clearly 16 into 18 will be divisible by 8. So we could check this with any other odd number. So this means when n is an odd number, n square minus 1 will always be divisible by 8. Now let's see how to work this. Let's consider the positive integers, odd positive integers 4q plus 1 and 4q plus 3. We know that 4q plus 1 and 4q plus 3 are odd positive integers. Correct? So let's consider them. Now when n is 4q plus 1, what is n? What is n defined as? N is a odd number, odd positive integer. Now this 4q plus 1 is an expression that represents an odd positive integer. So when n is 4q plus 1, what have we to do? We'll have to find n square minus 1 and show that it's divisible by 8. So let's find n square minus 1. This is n. I repeat, this is the odd number. We need to square the odd number and subtract 1. N square minus 1. This is the odd number. Square it and subtract 1. This is the result we get. Now we need to show that this expression is divisible by 8, which means we have to take out 8 common. So n square minus 1 is equal to 8 common, 8 of 2q square plus q. We don't have to bring out the HCF. The HCF of these two terms is 8q. It's sufficient if we take out 8 common. So we have 8 into 2q square plus q. Clearly n square minus 1 is in the form 8m, where m is equal to 2q square plus q. Now when n is 4q plus 3, so what is this again? This represents an odd positive integer. Now we need to square this and subtract 1. We need to find n square minus 1, n square minus 1, and show that this is divisible by 8. So n square minus 1 is equal to, square this using the identity a plus b the whole square minus 1. So this simplifies to 16q square plus 24q plus 8. Now the three terms have 8 common. So bring out the common factor 8, and this is what we have. Clearly n square minus 1 is of the form 8m. 8m. So this means it's divisible by 8. When you can express this as 8 into something, it means it is divisible by 8. So clearly n square minus 1 is in the form 8m, where m is equal to 2q square plus 3q plus 1. This proves that the square of an odd number minus 1, the square of an odd number minus 1 is always divisible by 8.